The socket head cap screw is one of the most commonly used types of screws. If you have no idea about which screw to choose, you can simply and safely opt for a socket head cap screw. For example, if one part has a through hole and another part has a threaded hole, you just need to pass the screw through the part with the through hole and then screw it into the threaded hole to fasten the two parts together. Another installation method is when both parts have through holes. Pass the screw through the two through holes and tighten it with a nut on the back. This is a common hexagonal nut, which can be tightened using an open-end wrench or a socket. Now, let's introduce several types of nuts. This is a flange nut. It has a ring of teeth on its outer circle, which can grip the workpiece tightly. In addition, due to its wider contact surface, it can sometimes serve the function of a nut with a washer. This is a lock nut. It features a rubber ring on it. A lock nut must be tightened with a wrench. If your equipment operates in a situation with a lot of vibrations, you can use a lock nut to prevent loosening. Even if the lock nut is not tightened completely, it won't loosen. Therefore, for some simple link structures, in order to omit the bearing, a lock nut can be used to connect two links without tightening it completely. This is a cap nut. Its advantage is that it looks more aesthetically pleasing. However, the length of the thread it can accommodate is limited, so you need to choose an appropriate screw length. This is a square nut. Compared with a hexagonal nut, it is less likely to slip. For example, when embedding a nut in a 3D printed part, using a square nut can withstand a greater force than a hexagonal nut. In addition, there are also thin square nuts. If the thickness of the part where the nut needs to be installed is insufficient, you can use a thin nut to achieve the same function. Next, let's introduce some washers. The most commonly used washer is probably the flat washer, which is generally made by stamping. Note that there is a slight difference between the two sides of the washer. One side is relatively smooth and shiny, while the other side is relatively rough. When using it, we should press the rough side against the part. Using a washer can increase the force-bearing area and avoid damage to the workpiece caused by repeated disassembly and assembly of the screw. This is a spring washer, which is made of elastic material. The function of a spring washer is to prevent loosening, and it is generally used in combination with a flat washer. First, put the spring washer on the screw, and then the flat washer. In addition to the spring washer, this double-sided toothed washer can also play a role in preventing loosening. The teeth of the double-sided toothed washer are relatively dense, so it is thinner and less likely to damage the workpiece. This is a low-profile socket head cap screw, which is thinner than a regular socket head cap screw. For example, when machining a screw hole in a thick part, the countersink is relatively deep. But if the thickness of the part is insufficient to machine such a deep countersink, you can replace it with a low-profile socket head cap screw, which can be embedded in a shallower countersink. This is a countersunk head socket screw, which is generally installed with a 90-degree countersunk hole. For some very thin plates, such as a computer case, it is impossible to machine a flat countersink in the plate. In this case, a 90-degree countersink can be machined and used in combination with a countersunk head socket screw to keep the screw from protruding from the surface. This is a button head socket screw, which is more